There was once a critical problem in the world of computer networking. There was to be a shortage in network addresses that would have severely hindered how we communicate through the internet. However, there was a resolution that I believe was one of the most profound developments ever made in the area of telecommunications and networking. Before IP version 6 was developed, the standard for network addressing was IP version 4. Many of us have seen these numbers when connecting a smartphone to an access point, connecting a laptop to a home network, or you may have even seen your company's tech support run an ipconfig command when troubleshooting. So what exactly is this number? This number represents a unique identifier for your device for sending and receiving data. This is a 32-bit number that's divided into 4 octets and can be numbered from 0 to 255. An example of what the address looks like is a 192.168.1.0. Internet service providers around the world are granted their own specific range or ranges of public addresses. In the home and the office, the router is the device that will translate those public addresses from an ISP to a private address that is used at the local level. This is the basics of how you connect to the internet. Think of the network address as like your home address. Would it be possible for someone to send any kind of message if your address did not exist? We would be flinging pieces of mail out the front door and just hope that they would get to the intended person. The IP version 4 problem. Roughly 20 years ago, it was determined there would be a shortage of available public IP addresses. Given the number of digits and numbering within an IP version 4 address, there are only 4.3 billion possible combinations, and right away 600 million of those are taken for special purposes, leaving 3.7 billion possible addresses available. The current world population is over 7.5 billion, and right away there is a critical problem. There just are not enough possible addresses for everyone, even if we were all limited to just one device. Through the use of subnetting and logical ports within a router, we're able to prolong the use of IP version 4. However, this is not a permanent solution. Subnetting allows further dividing of the already available addresses without causing conflict. Just think if there was a duplicate address of your home in the same area, would you be able to receive all your mail? The term Internet of Things has been used frequently in the recent years. This is the concept of many network-capable devices existing today that connect to a typical network. We have gone from just computers to many devices and appliances that can connect to the internet. Such examples include smart TVs, smartphones, tablets, home thermostats, and even kitchen appliances such as stoves and refrigerators. So already there are not enough IP version 4 addresses available for everyone, even with one device, let alone trying to connect 5, 10, or more devices in our homes. Then you factor in all the worldwide businesses and corporations trying to connect their devices to the internet. There's just too many. Something had to be developed to fix this problem. Enter IP version 6. This addressing scheme allows a massive amount of potential unique addresses. Unlike its predecessor, IP version 6 uses a 128-bit hexadecimal format that is divided into 8 quartets. Each placeholder can be numbered from 0 to 9 and A to F. One hexadecimal digit represents 4 bits, and the number 0 through 9 still mean the same. 5 is a 5, a 7 is a 7. And then with the letters, A equals 10, B is 11, C is 12, D is 13, E is 14, F is 15. And in the computing world, a 0 always counts as a placeholder to make the 16 digits. IP version 6 was first published by the Internet Engineering Task Force under RFC 2460 in 1998. This document describes the definition, purpose, and functionality of the IP version 6 protocol. The potential amount for unique addresses for IP version 6 is 10 octillion times what IP version 4 could provide. In other words, you need to get out your calculator to try to compute that number because it is very large. This is the breakdown of the IP version 6 address. The first 48 bits, as seen on the left, are used as the global routing prefix. This is followed by the next 16 bits for the subnet, and the remaining half of 64 bits is used as the host bits. An easier way to understand this is to recall the mailing address example mentioned earlier. The global routing prefix would represent an identifier for a country, followed by the subnet, which would represent your zip code, and lastly the host bits would represent your unique mailing address. IP version 6 serves as an all-in-one package for addressing, unlike IP version 4, which uses different processes to route data to IP version 4 addresses. IP version 6 resolved the shortage issue. However, there are some additional features. It featured a new header format which reduced the processing time for routers. Through IP version 6, it has the ability to automatically generate local addresses without the use of a DHCP server. This protocol also utilizes a built-in security with IPsec, and this implements a new communication protocol known as neighbor discovery. This allows any IP version 6 device to communicate with other similar devices without any configuration being made. There are many legacy or older generations of computer and networking systems that are still in use today. For the present time, each generation of network device will continue to be IP version 4 and IP version 6 capable. It is almost impossible to determine when everything will be IP version 6 only. In the future, that time will come, but we will never have to worry about a shortage of network addresses for the global population again. This concludes my presentation. Thank you for viewing, and I hope you enjoyed it.